presentation is very much in line with all the EU new trends and regulations. I would like to ask the audience to pose questions, and obviously the first ones will come from our architect professors, specialized in wood.
Hello, thank you. That was incredible presentation. Very, very interesting examples. I think this is the future, and it's really promising that you have already worked on this and tested also in practice, because theoretically we can say a lot, but the most important is to see that in practice. So my question is, I'm a structural engineer. I teach in the School of Architecture, but I am a structural engineer. Concerning the reused material, the timber grading for the structural elements, because this is a really difficult part. And I know that now, I can say that after you answer, yes.
Sorry, I didn't really dwell on this in depth. The peat pond that I showed, that's the project you probably addressed. We had a master thesis running, so the engineers from our office, and the student calculated the static calculations, and he took the timber into back into the university, and he did testing in order to investigate the strengths of the timber, so that he could bank his calculations on. So this was one approach, which is time-consuming and costly, of course. And at the moment, there's a project funded by the state of Baden-Württemberg. They look into the reuse of steel and timber. It's at KIT, and they try to come up with a formula how to calculate it to make this whole process easier. Because you need to know the strengths of the timber. But I mean, Hans-Uli, you might want to add to that. We believe that the structural integrity, you have a visual sorting process that you can investigate. So visually you can investigate the timber, and you can also do it by machinery, and then you should be able to define the strengths class, and you should be able to carry out your calculations. But we need to prove at the moment still how this process works in order to establish it, that it works in a much more time-efficient way. But this was the approach in this project.
I would add to that so for non-load-bearing structure is easier to reuse them, but for load-bearing elements needs that strength grading in order to reuse them. I would like to say that this now in Europe they started a new Eurocode for existing buildings, which means also structural engineers understood the need to work on existing buildings. So now I am in the working group of the standards for the existing buildings, and of course there is a new part for existing timber buildings. And so in these cases, you can, we discussed that you can use also the strength grading rules that we use for historical buildings. When we have and we want to make a restoration, always we do a visual grading or whatever in order to characterize the timber, in order to make the restoration of an existing building, of a historical. So in these existing buildings that you can use the rules that are already used for historic buildings. We have done a paper on it, and also a European standard norm. I can send it to you for this. And also I want to say that now is running a cost action on timber tall buildings. Maybe you are aware of it? Timber tall buildings. Cost action for tall timber buildings. And in this cost action, there are several groups working exactly on what you are addressing.
Okay, interesting.
On timber, And a very important discussion, it has 2 years more to continue, so I think that we could make a contact with this construction. In these next 2 years, they're working hard on exactly on the topics that you are saying. Mainly not on structural, but on thermal and energy aspects.
Yeah, okay.
In
No,
a
that's
holistic way of approach. So
Yeah.
I would suggest that maybe during our group we can discuss it, how we can contact, I am in the management committee from Greece, but how we can contact our research group with you. There are a lot of things going on because they are working on the state of the art for this.
Yeah. No, I think that's very, very useful, and we shorten sort of like the learning curves because we share the knowledge. That's
And the
very, very useful.
dissemination,
Yeah.
yes.
No, absolutely. Thank you.
I think Sina could maybe better introduce it, but we have a parallel research project going on for the load bearing structure of the pavilion, and we have a kind of a mobile timber grader system what starts to investigate the timber a little bit, and then there is also the standard grading, and our GluLam partner, he imagines, okay, if we send them ready lamellas, and then he would send it to his scanner, and then he would just use it. That's something I think to use old wood is something different, and but there's still a gap, and it's very good that we just connect the two projects, I think.
Actually, I think you're absolutely right, because in existing buildings, you cannot see the ends
Right.
of the timber. Now you have ultrasound elements that you can use them when you take them out, you can dismantle them, and you can this portable ultrasound grading system, yes.
Right. But that's very good to connect this, that's very good.
Practical discussions. Questions? Any more comments, ideas that could help our project? Yeah, Zeta.
Thank you very much for the very interesting presentation. I realized that we have common obstacles during our works as architects in creating new constructions, also renovations with recycling or bio-based materials, also in your country as well as ours. I would like to ask how have you faced the fact of the biology of the material? I mean that wood as a recycling material, because of the fact it is a natural material, it has been attached very probably in old constructions by microorganisms or that, and because of the fact that we are going to research here the reuse of wood. If you have obstacles in that, what have you seen during your experience, and how we probably have to manage with this problem?
In the peat barn project, I wasn't working on this. This was before my time at ZRS. I don't even know if you had infestation of micro. But you need to make a survey, so you can investigate and you can detect the parts, and there are specific rules that you need to cut out such sections in order to make sure that you don't sort of like scrutinize the remaining parts, and you can repair the ones. I didn't show this in detail, but there were a few ones where the structural integrity wasn't given, and so some parts were fully replaced, but in others, with the columns for instance, they didn't, it didn't affect the entire column, so they cut only parts of it out and replaced the missing parts, and that's how you repair, and that's sort of like the rule. Because of course, if you have an infestation or if the structural integrity is not given, you can't use this pieces. But that's sort of like in comparison to the overall structure, it's, I would guess, 5% or something, very, very limited. So that's how we approach such problems. And normally, I'm not an expert, but normally the experts, they they have sort of like the initial sort of like investigation, and if there's my English today is if they have sort of like the fear that there's something wrong, then they take it further into the investigation, and normally that's safe enough to avoid to have infestated parts in the new construction. But you need to address it, yeah.
But doing a detailed investigation is the most important. If you find a resource, first thing is doing all that resources, no? on bio and also chemical products, treatments. That's a big problem. But if we started now putting up our screen, finding timber, so there are a lot of construction. So there, for example, there's one huge Berlin block completely done in the 1990s. And they just demolished it now. So it's like new wood, you know, and there's a church from the 1960s, what is a fantastic wood. And so that's quite interesting what's coming up now and how much is going to be demolished at the moment still. And then you need your investigation. You need for sure resources to do so. And the best thing is that you have already an imagination where it goes and what you could use it for at the end. No? So then you start cutting things right on the construction site already, et cetera, et cetera. But that thing's that's all very steps for the future now. That's very new now, but we did some learnings there. And we're sure that we quite can collect a lot of our materials, what we use for the pavilion. So especially for the walls and the ceiling systems, it should be quite easy. But then it's the question of a mass, how much material we can afford to get into the building. No?
And that's also why we argue that we need to keep our buildings again for much longer lifespan, because I think this thinking of you demolish a building after 50 years is just, it's not working in the future. This was just a very limited period of time where we had the idea that this could be sort of like a strategy, but we come to a point where we understand that the depletion of resources is not just about the resource itself, it's about the ecosystems that we completely kill, and this is our basis for living here on planet Earth. So I think it's also a mindset that we need to change, and this is probably the most difficult one.
Yeah, well, in an ideal world, that would work. Unfortunately, our world is not ideal, as you know very well, and there are sometimes obstacles that change the route of history, and of course construction is part of it.
Absolutely.
So I just wanted to, as a follow-up of this question, are there any regulations at the moment regarding the long-term, the aging and the durability performance of the recycled or reused timber? Because that has to do a lot with the local climatic conditions and the type of a construction that you...
Yeah, I'm not an expert in that, so we have our civil engineers working with that. There are research, but that's really also at the beginning, and that's also looking on a very long period. And then it depends how much major loads it has or not, or if it's fully like 100% use of the load-bearing capacity, and then it's got more strengthening, and then it's getting some aging, but I will quite end the beginning, and then we're going to see to investigate what it takes if a timber was very high loaded, or is it less loaded, etc., etc. So that's something, I think they're still at the beginning, no, with that research. There's the micro. Please use the mic that we...
We don't consider age for timber. There is not aging in timber. I mean, age like humans age. Maybe sometimes there is better. The structural strength of timber may be better after some period. So
yeah, but not with the recycled
in the beginning
one.
Now.
The reused, the reconstructed.
I think the challenge is going to be the glue. I think this is
exactly.
going to be the problem, because
Exactly.
we have all these modern products, and as far as I'm aware, the Eurocode sort of like does the calculation for 50 years, but after 50 years we don't have long time experience what happens to the glue, and this might be a thing. But again, there it's quite interesting because the timber manufacturers, I think they are aware that also glue has an impact, and that you can't take sort of like a beam that has been glued back to nature. So you need to, at some stage, you need to burn it, and the aim is really to develop more and more products without glue. So this is also quite interesting to observe and to see, and that there's a lot of development going on. But again,
I think this is indeed
things
the
to be done.
challenge. Yeah.
Thank you for presentation. It was very nice and I learned a lot today, but I can just point out that in Japan, for example, they use a lot of timber, and they're in the process, like we're here in Europe, they build something and on the next plot they demolish something. So they don't even last 50 years, the buildings. So because they have that, let's put it this way, they want to every time have something new. So every building doesn't last even 20 years. And they want to recycle, reuse. So maybe we can learn something from them. They're trying to eliminate that and to use timber more. So Kengokuma also use a lot of timber. So maybe finding something from them, because they are building shrines that last for 100 years with timber. That's also something really productive, and we can use that as an example for us, so we can also implement that.
We discussed this also, I mean, also with Daniel, my colleague from Switzerland. The question that I really have, yeah, who's sitting here, sorry. The question that I have is how we can, because it's not only a technical process of dismantling something and reassembling it, it's also a question of logistics. So we need to store it somewhere. This just-in-time availability will be very, very complex and very, very difficult. So this is also a factor of cost that we need to consider, and then also transport. And if I try to imagine that we have all of a sudden, we have, let's only say 1,000 buildings being taken down at the same time in Berlin. I don't want to think about it, what happens to that? So that's why I think we need to keep buildings, again, a lot longer in use, rather than having this idea that we can now develop something, it's following the circular principles, you take it down again, and I'm a bit scared of this idea, but we can I'm open for discussion.
Actually, this brings us to one of the topics of our greenest project, which is the reorganization of the value chain and the re-evaluation of the business model that it is needed in order to promote a nature-based solution construction. And we all know that this is very much at the very first stages yet. Mass reproduction of this type of construction, I think it's not possible yet at the moment, and especially in an urban environment. I think that it may be more feasible to realize it in a rural environment where the construction is not so dense and the typology of buildings is not so diverse as it is in an urban environment. And I believe that it will be a challenge in our project, since we have 2 new buildings that are constructed in Berlin. Berlin, obviously, it's not a rural environment. And we will also have 2 buildings that are going to be constructed in in a rural environment, in an island in Greece, and in a protected area in Italy. So we will have, as part of the project, to look how we have to reorganize or organize the value chain in order to be able to get the resource to overcome problems in the logistics, to organize models in the deconstruction of the previous building to reuse the material, and obviously to get the involvement of the local citizens, of the inhabitants and of the population, because I think this type of construction is also a co-creation approach. So I think we will have a lot of things to discuss in our project. Today we had, I think, a very good overview and in-depth overview of the structural and envelope materials. We haven't covered yet the insulation materials, the windows, the energy systems, which are also the control systems, which are also part of our project. And I hope that in our next meetings, we will have the chance, a similar chance, to get more information and insight in all the aspects that our project looks at. So thank you very much for this detailed presentation and in-depth, and I think we all learned a little bit more today. And it's now time to have some coffee and start the actual meeting of the project.